So don't forget, if you have any question, just raise up your hand using the button so that you can be recognized to ask your question. Okay. We give priority to the question here today, then we answer the other ones once we are done. Okay, our professor is raising our Professor Taufik. You have the floor. You can unmute yourself.
Yeah, good morning.
Good morning, Prof. We are with you.
I think his mic is muted again.
You mute, okay? Prof, since you are
sorry,
okay.
sorry.
Okay, yeah.
Okay. Yeah. I said what caught my attention in this discussion this morning.
Yeah.
Is as regards this methane emission reduction. That particular task is standing in between environmental concern and production to foster the sustainable production that you mentioned.
Yeah.
Now, I want you to assist us to look at the kind of data that will be of interest to pursue this particular goal in machine learning research. Because it's very interesting to me because one will be fulfilling two things at the same time when we embark on such kind of research. We'll be fulfilling a veritable pathway for production, sustainable production, and then also of environmental concern. So the such kind of work will have a relevance in both fields, the core of production and the core of environment. So I want you to assist us with to mention the kind of data and the items in the data that will be necessary for us to have this kind of research using machine learning model.
Okay, thank you very much, Prof, for the question, as also for the attendance, and also always being proactive and be one of the active participants. Highly appreciated. Yeah, it's a very wonderful question and a wonderful area actually we can look into. So data is usually the big issue, and there are a lot of ways that data could be gotten. Number one, the first thing is to look for data sets, free data set online on this particular title. That's the one way to look at it. So, and usually we request our coordinators to kindly help us post some of the research groups. I know the Greek group being led by our professor. They are already communicating and try to come up with some things. So the coordinators should please help us broadcast again to announce all the groups and their leader, to provide their link so that interested people can join each group that they want to join. So that we've seen a lot of people came up and they were able to get mentored, and they started actually using this technology in their different various ways of endeavor. So on the methane emission, the standard thing to do is, first of all, we look into data set. We don't say this data is not going to work. But first of all, we understand how does it work. Professional in that area will look at, okay, if we can reduce methane emission, what is going to be the advantage? If we optimize the feed, in what way? It doesn't mean we should not feed the animal. Like I said, if you don't feed them enough, they will not produce. If you feed them too much, they will not produce also. So you have to be in between. However, in methane emission, there may be some compounds that will lead to more methane emission than others. This is where prescriptive analytics will come in. That while producing the feed, which kind of recently people started talking of benign chemistry. This is an area that people need to focus on. One of our professors recently presented a very nice inaugural lecture on the benign chemistry and how they can use it to treat for water treatment. So in this similar way, can we also look in that direction? So that is chemical that they are less harmful to the environment. Can we utilize them in our field production? Because a lot of possibilities that we are not pushing, we're only using what people already use successfully. But a lot of things that we can actually divest to. So that if the feed is normal, like we know, there are some food, even as human being, when you take the food, you release more gases than when you take other food. So a similar way, maybe if you can go into benign chemistry, we'll be able to say, okay, can we have some compound that, some chemical that can help us produce feeds that can lead to lower methane emission while also not affecting the production of our animal. So it's going to be a very nice work. And I see possibility of having a well-written I will suggest to our professor to let us look in the direction of writing a very sophisticated proposal, because it's going to be a big event-changing research that will hopefully support and make animal production interesting one, and also in line with the sustainable UN mandate or target, as the case may be. So we'll start by looking at online, a quick research, what are people be doing in this respect of methane emission and sustainability and production, animal production optimization. So have they been working in this direction? Then let them bring in, we bring in the data, we look at what they have done. If no one has ever worked on it, which I doubt, then we now sit down with the expert. What are the things that determine your feed? What are you used for your feed? Can we look in another direction? Some other new chemicals that are coming on, which they call benign chemicals. They call benign chemicals. These benign chemicals these benign chemicals, they can produce the same feed we have been producing before, however, with lesser side effects. So we look into that, and also we look into some of the other possible combination. With prescriptive analysis on our side, I believe we can be able to come up with something really big in this very interesting area. So this is my submission for now, Prof. So we first of all look, you can assemble interested people in this area under your subgroup. And the way it goes is in each subgroup, once a topic arrives, then we ask for people who may be interested in that topic. Then another subgroup will be created in the WhatsApp group again for that new topic. And those people will start working. Some people will do literature survey. The procedure we usually itemize is you do quick literature survey, see what has been done, then see the gap that is there. How can you come in? First of all, look for online data sets. If there's online data set that has been used before with lower performance, lower accuracy, go there, try to improve that accuracy first. Do feature selection. They are using like 50 features to predict, and they are getting 85%, even 95%. Can I reduce it to 5 features and I can still get 95% like they got? That's a huge improvement, because getting 50 features collected is not a joke. It's tough, it's costly, it takes time, and also other disadvantages. So if we can use the same data they have used before, but now we are doing feature selection to cut down the number of features we need to look for, then we are contributing a lot in that respect, irrespective of the area we are working on. Then once we are done with that, then we now look inward. How can we now produce or reproduce the same data locally? Because data sets from one country is different from data from another country. You see? So we now say, okay, can we build a system that can generalize even across country-wise? That's a big work. Another next stage in AI and machine learning model building, which is very tough. We call it heterogeneous data. Presently, what people are doing is data limited to different characteristics. Because the animal in Nigeria, they have some unique characteristics to the one in another, even African countries, not to talk of other continents. So we use data based on that. And later, with Ensemble, we can think of possibility of having a single unified generalized predictive solution that can work across continents. That's going to be a tough one, but personally, I don't believe anything is impossible. It is possible. It needs efforts, more effort, strategic plan, and also the action to follow up. So that is it for now. So once we have that in each group, then we can then be able to see how we can come up with data set that is relevant and local. But at the beginning, I don't want us to be limited by local data only. No, let us use whatever data that is available. So going forward, let us search for data related to maintain emission, feed optimization, and see what people have done in the past. That will give us a lot of insight. Data, we can then, even after getting the data, you'll be surprised that some data they are even using is not relevant. You can remove them. Then we can come up now and say, okay, sit down with experts, let them give us some recommendations. Then we can come up with our own data collection, of course, which is going to take time. That's why we don't stop until we get data. We start using the online data we get first, while we're looking towards our local data generation. Thank you very much, Prof. I hope I have responded to your question.
Yes, very well, sir. Thank you very much.
Thank you. So I can also see, yeah, I think there's the Prince Adedeji. You have the floor. You can unmute yourself.
Good morning, sir. Good morning, everyone. Thank you very much, Prof, for this interesting topic.
You're welcome.
Based on the last question, because I had 3 questions I wanted to ask, but I just wanted to quickly say something about the last question. What's the minimum data size that can be used to create test models for this kind of projects, like the minimum size, like samples, let's say, okay, 500 or 1,000.
Okay. Okay, that's the first question, eh? Hello, Prince.
Yes, Prof, you can go ahead with that. Just go ahead with that, Prof.
Okay. Yeah, as for the minimum or maximum number of data sets, actually in machine learning, data science and analytics, we don't talk about minimum data or maximum, but the more the better. See, the more the better. We get as much as possible, because some of them might be noisy data. Later, they're in line with the principle of letting the data speak. You see, why I say that we don't talk of minimum is, but the more you get, the better. We've had modeling with 16 samples with very huge successful outcome. 16 samples. Of course, you have to look in the direction of some algorithm that have that capability to work with fewer data sets. It's an abnormality to have very few data, but in some area, they tell you, your client will tell you this is the maximum we can get, 16. Then in that case, we're able to deploy support vector machine, which has some unique characteristics in dealing with few data samples. It's not usually affected by the cost of dimensionality. We had in the past several weeks of discussion on support vector machine. We can search our YouTube channel and we can look at support vector machine. When you face the prospect of very few samples, you can go for support vector machine. I can strongly recommend it for you. However, I'm not guaranteed that it's going to work in our situation, because the principle of let the data speak holds. So, but having 500 samples is a very good one at a task. 250, 1,000, but the more, the better. However, whatever you have, start using it first. Because sometimes I had someone who was having data like 200, and then he kept looking for 2 months, I said, how far with your project? He said, I'm still looking for more data set. I said, how much you have? He said, 200. 200 is more than enough to start. We've modeled with 16 samples before, and we had excellent result. 200 is already on the a little bit average data sample. Start your work. And surprisingly, he started getting he got very nice result. So why we are adding more? Because another way we could look is data does not have to be collected actually freshly. You can actually get data from published paper. Some people don't realize this. You search for paper in that area, like this maintain we just mentioned. Some people in the past, they have worked on this thing, but they did not use machine learning. They just work in the lab, take some measurement and publish with their paper. Extract that data from the paper. Extract from another paper. In fact, there was some work we did on material science. Because there's no data, is very difficult to get there. We have to go into publication, extracting data that are related. Also, when we work on high-rise building analytics, we have to collect data from different published papers. And we put them together, and it became a very huge, successful modeling, and then the outcome was really great. So, in the principle of let the data speak, we don't limit ourselves to whatever we have, let us start with it. It is the data that will tell us that, oh, I'm not good enough. You can't do anything with me. So whatever we have, no matter how minimal, 16, 20, 50, 80, 200, let's start with it. Start with simple algorithm and keep data, k-nearest neighbor, logistic regression, decision tree, neural network, support vector machine. If your data is very, very small, you can be sure neural network may not work for you. Support vector machine, k-nearest neighbor, decision tree, all those simple algorithm, they may work for you. Logistic regression. However, XGBoost, before you start going higher into building ensembles and the like, because in the principle of let the data speak, people jump to using very sophisticated algorithm like deep learning. I've seen it a lot. Meanwhile, you need simple algorithm to do it. Just a few days ago, one of my students was reporting to me, the trainee, said he has used XGBoost, he has used a random forest. These are ensemble on that data. But later he recommended that let me use logistic regression. And surprisingly, he achieved 100% full accuracy with what he was ignoring before. That is why we must always let the data speak. The principle of let the data speak means use simple algorithm, keep advancing if the simple one fail. But don't jump to senior one. Some people jump to deep learning and they get 85%. We later realize simple algorithm like k-nearest neighbor could have gotten 95% or 98%. So this is the principle we have to bear in mind. Let the data speak means whatever we have, bring on the table. There's no minimum and there's no maximum. Next question, Prince.
Yeah, I'm sorry, I went off because there was a network.
But I hope you catch part of it, eh?
Yes, I got the response to the question. Thank you very much, sir.
Okay.
The other question is I don't know if you got the part I talked about drones and satellites imagery for irrigation farming.
Yeah.
Yeah, so I was like, so when it comes to drone technology powered by AI,
yeah,
how is it effective for irrigation in farming? And how does this ensure all year food production?
Thank you very much. This is the very nice and futuristic issue. However, it is already happening in a lot of lands that are using mechanized farming. And it's the way to go because the classical irrigation we have, we irrigate at set time and interval, not based on the need of the plants. So precision agriculture has made it possible for you to determine which of the plants area actually are in need of the water. And like has been stated in the question, drone technology can be deployed to target predictive solution will go first of all work. Monitoring the area. This area seems to be in need of more water. You drop different amount of water based on the predictive solution that you already built. In that case, this is called targeted irrigation, not just providing water for all the plants. The consumption rate is different. In one place, it may be slopy land, which means the water that is dropping on them is going downstairs. Others are benefiting. But the next time we are irrigating, we only irrigate everybody once in a, maybe twice in a day with the same amount of water. Meanwhile, some are not staying because they are washing away, or while some are having too much already. The one in the slopey side. So targeted irrigation using drone technology will ensure that plants are being provided with needed water and even the right amount of water. It's becoming possible to determine. When you take pictures of plant, you know the amount of water that this kind of plant will be in need of. And then drone will be deployed to irrigate according to the need of the plant and those around them. So it's a possibility, and it falls under what we call the precision agriculture. So, and it goes a long way to minimize water consumption. You see, you don't just drop water for plants that are not in need of it. See, that will also lead to water logging later. I've seen a lot of places where they do irrigation. Of course, that's what we have. They just road around, dropping water on the plant. Where some areas are slopy, the water doesn't stay much. Compared to those ones that are down, they still benefit from the out of their peer that are upstream. So with this kind of mentioned drone technology, I believe it can go a long way towards revolutionizing the way we do irrigation in plant production. Thank you for the question.
All right, sir. And this is my last question. I'm putting myself as a research student who wants to collect data from a small-scale farmer.
Okay.
What kind of... I know the next topic is about the challenges facing AI adoption or that are actually in place for farming. But what advice will you give a young researcher who wants to go to a small-scale farmer? Let's say someone who is actually having a small fishing farm or a small poultry farm. What kind of data collection method will be?
Okay, thank you very much for the question. See, on data collection, is one of the challenges we are going to talk about later, but we'll mention it briefly. It's not a once at a go issue. It will be in stages. Initially, we have to discuss with the practitioner. Those people are there. In fact, there was a time, one of the research groups who wanted to work on farming like 2-3 years ago, they actually spoke about this idea. And I think one of them later dropped out because he had some issue, he had to travel, and then so they couldn't continue. They were going to actually have people to talk directly to farmers. There are a lot of things that are wasting away in terms of data. Let the data speak. And farmers, some of them may not be educated, that's fine, but we speak to them. We talk to them. We gather the necessary data. But recently, I have seen that in universities, I've been saying it and I will say it again. I'm really motivated. My university presently has Faculty of Agri. I'm actually motivated by the students. They're very hardworking. They're always on their farms, their poultry, where other students are playing around. I was really, really motivated that really we see have this kind of youth. Some of them, even though they're not computing, they started coming already. So my office is just not far away from their faculty. They're coming around, bring their laptop. They've started collecting data. We analyze it. This data may not work. Go and collect this one. For example, you want to monitor, you want to know the amount of food you should give to your poultry after 1 week, after 2 weeks, after 3 weeks. That's okay. Is it possible for you to know the amount of feed you've given them before so that we can have either a time series problem or a usual data supervised learning system? So they collected the data. We said, okay, go back, collect this one, go back, collect this one. I will have to be a kind of a handshake between the practitioner, those who really want to help them build it, and those that are actually involved in the actual production processes. So we were able to know, okay, what are the data that is possible? Let them bring it down. We see which one can we use. Sometimes we needed something they don't produce, they don't get it, but they have it, but they don't record it. They said, oh, I didn't know we are going to need this. We can get this. They went back. After a week, they were able to bring something again. And I'm happy they're making a lot of very good progress. Undergraduate students, actually. So imagine if it has to be postgraduate student, I believe they can even do even better. So they have to be a kind of, that's why Research Institute, as we know, they are always the forerunner of implementing new ideas. Later, it goes to ordinary people in the street. So if we want to also include the ordinary people, then we have to do more work, be ready to interact with them so that we'll be able to get our data set. But for sure, Research Institute, universities, they are actually more responsible in this area. And I think they should take the lead in making our data available. Agencies should be made to have data. Like the IATTA, what we call it in Ibadan. There's very popular agricultural center and other research institute. If their data, a lot of things have been done in the past, but I'm not sure if we keep those data sets. But things are changing. Those data set has to be made available so that we can all benefit and take advantage of this new technology that is taking over the landscape. As I said in one of my three or four series videos, why we can no longer ignore AI and machine learning. So with data analytics integrating into it, the opportunities is just too huge for anyone to ignore. And as they say now, that the next oil and gas is data. Is data. So hopefully we'll be able to see how we can get data optimally from our farmers, practitioners, researchers in this area with adequate and appropriate collaboration. Thank you very much, Prince, for that question.
You're welcome, sir.
Okay, thank you all for, I believe there's one question here. So thank you for the great presentation. What supportive infrastructure can youth push forward for meaningful investment that enables more output of this work? Considering the prospect for multi-sectoral collaboration from your experience, what baseline presentation, requisite skills will you encourage teams that have interest in working on AI solutions to consider? Well, like I've stated, your first question is not very clear. So, but for the second question, yeah, we set up this platform that we want people as much as possible to embrace AI. It's an awareness platform for people to be aware of the huge potential they can actually tap into in AI technology. So, and we made it simple. We say AI for all. So don't worry if you are new. Our coordinator will post, just join the YouTube channel, join the YouTube channel, of course. Join the WhatsApp group. Once you have a newcomer, they will post, there are 4 videos, introduction to machine learning, and another 3 videos, build your first model in weaker environment. You don't need to be a programmer. If you're a programmer, it's another advantage for you. So, and I can assure you, young chaps, undergraduate, they're already doing that. After watching the first 4 videos, which is introduction to machine learning, basics, the next 3 videos demonstrated how they can build their first model in a weaker environment. And within 2-3 days, the students are already building this. A lot of people, medical doctor, people who are not even having any computer background. So you can make it and you're all welcome. It's not difficult. It is AI and machine learning made easy. And I can assure you, with dedication and then commitment, you can actually get it faster than you actually imagine. So They will post there the link to join the WhatsApp group. Try to join the WhatsApp group so that you'll be getting some of the announcements. And also, on the question, what supportive infrastructure can youth push forward for meaningful investment that enables more output for this work? Well, I'm not sure. I'm not sure if the questioner is around. Maybe you can put it more clear forward so that it's ambiguous. It could be interpreted in different ways, and I don't want to do that. So maybe next week I will keep the question. If the questioner is around next week, he or she can provide the explanation to what he or she meant. So we keep the question. So I believe that's a good place to stop because of our time. It's already 10 minutes past. Sorry for keeping you more than necessary. Thank you very much all for listening and for being patient. Wishing you all the best, and thank you very much, the coordinators, for being there. I believe they have been sharing the links to some of the research groups. You see different research groups are there, so you can join whichever one you want to join. Bring up idea with people there. People like mine, we work on a project. They create another subgroup to fine-tune it, finish it. I remember the geospatial group. In the past few months now, I think they have had book chapters, journal paper, and also further very nice outcome from them. The same thing in energy group, headed by our brother, Dr. Doctor from Kimfa University of Petroleum. So you have a lot of opportunity to collaborate with people from different backgrounds, different countries, and also different interests. So especially people that into research, I think you have a lot of opportunity to also tap into there, and also learning. And then businesses, irrespective of your area, you always have a group that suits your interest. And we really appreciate all the leaders, the coordinators, or the working behind the scene, the leaders of each group. We hope we keep the group active, and wishing us all the best. Thank you very much. Inshallah, till next week, hopefully, when we're going to have another edition. I say thank you. Have a very nice time ahead of you. Thank you.